Hello everyone. Today I'm going to solve this Sudoku puzzle from the Washington Post, and I'm going to use three very useful techniques: a swordfish, an XY wing, and a uniqueness test. I'll explain each of those when I get to them, and I'll leave a link to the puzzle if you want to try it on your own. Okay, let's get to the puzzle. Let's start off by running through the numbers 1 through 9 to see what we can place easily, and also I'm going to write in the candidates if they are restricted to just 2 cells in a block. That is commonly referred to as Snyder notation. So starting with the number 1, let's see. There are 2 1s in the puzzle, and there's not much I can do with those. So let's move on to the number 2. And there are 4 2s here, so that looks more promising. I can pencil in 2s here in block 3. Remember, I'm only penciling in candidates if they are restricted to 2 cells in a block like they are here. If they can go into more than 2 cells in a block, then I'm not penciling them in, at least not for now. Later, I'll need to switch to cell notation and start penciling in all the candidates, but for now, I'm sticking with Snyder notation for now. And let's see, here in block 4, I can pencil in 2s here and here. And checking all the other blocks, I don't see anything else I can do with the number 2. So let's move on to the number 3. And there are 3 3s in the puzzle, and I can pencil in 3s here in block 6, here and here, and here in block 2, I can pencil in 3s here and here. And now in block 8, I can pencil in 3s here and here. Let's see, is there anything else I can do? I don't think so, so let's move on to the number 4. There are 4 4s given, and I can pencil in 4s in block 5, here and here. And in block 9, I can pencil in 4s here and here. And here in block 1, I can pencil in 4s here and here. And block 8, I can pencil in 4s here and here. Okay, let's move on to the number 5, and there are 4 5s given, and I can pencil in 5s in block 9, here and here, and in block 4, I can pencil in 5s here and here, and yes, here in block 2, I can pencil in 5s here and here. Okay, moving on to the number 6. There are only 2 6s given, and I can pencil in 2 6s in block 1, here and here. Okay, I think that's it. 7. There are 2 7s, and it doesn't look like... Okay, here in block 2, I can pencil in 7s here and here. And now those 7s are locked into row 2, so there can't be any more 7s in that row. So I can pencil in 7s in block 3, here and here. And then the third 7 in this group of blocks would have to go in the 3rd row in block 1. But since that would be 3 cells, I'm not penciling that in right now. Okay, 8, and we have just 2 8s. And that lets me pencil in 8s in block 8, here and here. And that's all I can do, I think. Let's move on to the number 9. And okay, there's only 1 9 given, so there's not much we can do with that. Now let's see, we haven't been able to place any numbers yet. But wait a minute, let's have a look at column 4. This block has a 4 in it, so there can't be any more 4s in the block. And column 4 needs a 4, right? And in block 5, it can't go here or here. And in block 8, it can't go here. So we have a hidden single here in column 4. This cell is the only cell in column 4 that can be a 4. There's nowhere else in the column that can have a 4. So this cell has to be a 4. And this cell can't be a 4 anymore, so let's get rid of that. Great. Except now I don't see anything else I can do. This is a hard level puzzle, and to be able to see anything, any patterns that can help, I need to fill in all the cells with all the candidates. So I'm going to switch to cell notation and do that and come back. Okay, so now I've filled in every possible candidate in every open cell, so the Snyder notation wasn't that helpful in this puzzle, and really it's mostly helpful in easy and medium level puzzles, but for hard puzzles like this one, the Snyder notation doesn't have the same payout. So now let's have a look around, and right away I can see a matching 3-8 pair in block 2. So these two cells are in the same block and in the same column. That means there can't be any other 3s or 8s in the block or in the column. So let's get rid of all the 3s and 8s in the block. There are no 3s, but there are a bunch of 8s. And let's get rid of all the other 3s and 8s in the column. That leaves us with a naked single, the 5. And now we can eliminate this 5. And down here, we can eliminate this 5. And now there's a naked single, the 6. And once I place that, I can eliminate this 6 and this 6, and then these 6s in the block and in the row. And now I have a 3-8 pair and a 1-2 pair in column 4. And oh, there's a 7-9 matching pair here in the same block and also the row. So that means we can eliminate any other 7 or 9 in the row. Let's go ahead and do that. The 9 here, the 7-9 here, the 7-9 here, and the 7-9 here. And let's see. Here in block 3, the 7s are restricted to the top row. So the 7s in block 3 have to be in the top row, so there can't be any other 7s in row 1 other than these two. So that means I can eliminate the 7 here and here. And again, here in block 7, there's a pair of 7s locked in this row. They are the only 7s in the block, so we can eliminate all other 7s in the same row. And there's just one 7, so we can eliminate that. And that means this cell has to be a 1. Okay, let's clean up block 9 and get rid of all the other ones. And in the column, we can eliminate this one and this one. And in the row, this and this. And now there's a pair of 1s here in block 7. They are locked into the bottom row in the block, so there can't be any other 1s in the row. So we can eliminate this one here. Oh, and also the 9s here. These are also locked into the bottom row. There are no other 9s in the block, so the 9 has to be in one of these cells. So now there can't be any other 9s in the bottom row, and we can eliminate this 9 and this 9, and now this cell has to be a 2. And let's clean up the grid. We can eliminate this 2 and this 2, and up here this 2 and this 2. And now we can place a 2 up here in block 3. There's nowhere else a 2 can go in the block because of the 2 we just placed. So let's go ahead and make this cell a 2. And there are no other 2s in the block, the row, or the column, so no cleaning up to do. And here's another matching pair in block 6, the 8 and 9. These two cells are either an 8 or a 9, so there can't be any other 8s or 9 in the block. That means we can eliminate this 9 here, and this 9 here, and this 8 and 9. And let's take a look at column 9. There's a hidden pair in the column. Do you see it? So the 8, 9 in block 6 was very obvious, but this pair in column 9 is not so obvious. It's what is called a hidden pair, since it's hiding with other candidates. Do you see it? It's the 7 and the 9. There are just two 7s and 9s in column 9, here and here. there are no other 7 9s in the column. So these two cells are 7 or 9, and then we can eliminate the other candidates from these two cells. So we can eliminate the 6 here and the 1 here, and now you can see the 7 9 pair more easily. And then we have this pair of 1s here. These are locked candidates. They are the only possible 1s in the block, and they're locked into row 2. So there can't be any other 1s in the row. So we can eliminate this one and this one. And here we have a matching 7 9 pair in block 9. So there can't be any other 7s or 9s in the row or in the block. So we can eliminate this 9. And now let's look around some more and see if there's anything else. And let's see. There are 2 8s here in column 3, and 2 8s in column 4, and 2 8s in column 7. Those are the only 8s in columns 3, 4, and 7, and the 8s are in the same rows as well. So it looks like we have a classic swordfish pattern. This is similar to an X-wing pattern, except it involves 3 columns or rows. In this case, 3 columns instead of just 2. If you want a more in-depth explanation of the swordfish pattern, go ahead and watch my video on it. But right now, this pattern is going to let me eliminate all the 8s from any other cells in the 3 rows that are not part of the swordfish pattern. By the way, the 8 is sometimes called a fish digit, and the swordfish is one type of pattern using X-wing logic. Because the 8 has to appear in these 3 rows within these 3 columns, we can eliminate any other 8s from the same 3 rows. Let me show you how this works. First, let's highlight the 2 8s in column 3. These are the only 2 8s in the column, so one of these cells has to be an 8. One of these cells is true, an 8, and the other is false, meaning not an 8. Okay, we have the same scenario in column 4. Let me highlight those 2 8s. And again, these are the only 2 8s in column 4, so one is true and the other is false. And now let's look at column 7. These 2 yellow cells are the only 2 8s in the column, so again, one is true and the other is false. So here we have the swordfish pattern, an extension of the X-wing involving 3 columns. The logic is as follows. One of these 8s in column 3 has to be true, right? So let's say this is true, that's the first 8. Then this 8 in the same row, column 4, can't be true. And then this 8 at the top would have to be true, which means that this 8 in the same row isn't true, and then this 8 is true. So we have at least one 8 in each of these 3 rows that has to be true, so all the other 8s in these rows can be eliminated. Or let's flip that and say that this first 8 is not true. Then it would also work out. That would mean that this 8 is true, which means this 8 in the same row, column 7, cannot be an 8. So this would have to be the 8 in column 7, since there are only 2 8s in the column. And then that means this 8 in the same row, column 4, is not true. So then this 8 is true. Either way, one of the highlighted cells is going to be an 8, so there can't be any other 8s in the rows, and they can be eliminated. Here, let me highlight those 8s in pink. There. So now all these pink cells have 8s in them, and they are all in the same rows as the yellow cells that are part of the swordfish pattern, so we can eliminate the 8s from all these cells. So let's go ahead and eliminate all those 8s. This one, and this one, and this, and this, this, and this. Now, let's look around some more. And here we have a 1 5 in this cell, a 5 6 here in this cell, and a 1 6 here in this cell. Sometimes when you're looking for patterns, it helps to look at bi-value cells like these. A bi-value cell is a cell with just 2 candidates. Okay, now notice these 3 cells share the same candidates, the 1, the 5, and the 6. And yes, this is an XY wing. This cell with the 5, 6 is called the pivot cell with 2 candidates, the 5 and the 6. We can call them X and Y, which is why it's called an XY wing. And then these 2 cells are also bi-value cells, and one of them, this one, has the X candidate, the 5, and this one has the Y candidate, the 6. But they both have another candidate, the 1. Let's label that as Z. Now remember, I called this 5, 6 the pivot cell. Well, these 2 cells with the Z candidate, the 1, these 2 cells are called the wing cells. They're also called the pincers. Now, back to the pivot cell, it's either a 5 or a 6. If it's a 5, then this wing cell can't be a 5, so it's a 1. But if the pivot cell is a 6, then this wing cell can't be a 6, so it's a 1. So either way, whether this pivot cell is a 5 or a 6, either way, one of the wing cells has to be a 1. And so now any cell that sees both wing cells, they're also called pincers, so any cell that sees the pincers or wing cells cannot be a 1. And this cell sees both wings or pincer cells. It's in the same row as this wing and the same column as this wing, so this cell can't be a 1 and we can eliminate it from this cell. Okay, I'm not sure that helped much, but it was a good review of the XY wing. And let's keep looking around for more patterns. If we look at bi-value cells, here we have a 3, 8, 7, 9, and down here we have a 7, 9, and here a 7, 9, and this cell has a 7, 8, 9. Okay, so here we have a unique rectangle pattern. Let me highlight these 4 cells in yellow. Okay, now you can see there's a 7, 9 in these 4 cells, and you might remember from a previous video I did on unique rectangles that a unique rectangle consists of 4 bi-value cells that follow the 2 by 2 by 2 rule. That is, they are in 2 rows, 2 columns, and 2 blocks. And if we have just 2 candidates in those 4 cells, we would have an invalid puzzle. If not for this 8 here in this cell, then we would have only 7, 9 in these 4 cells, and then the puzzle would have more than one solution, with the 7 and the 9 interchangeable, and that can't be. A valid Sudoku puzzle has to have one and only one solution. So if not for the 8, we would have an invalid puzzle. Therefore, this cell has to be an 8. And now I think the whole puzzle is going to unravel from here. Let's clean up the grid and get rid of this 8 and this 8 and this 8. And now this cell is a 3. Now let's eliminate the 3 here and here. And that gives us a 1, 9 matching pair here. And we can eliminate the 3 here. And now we have a bunch of naked singles. So let's backtrack and place those numbers. This is a 9. And that means I can eliminate this 9 and this 9. So now I have some more naked singles. And I can eliminate the 9 here, and here, and here, here, and here. And let's make this an 8, and we can get rid of the 8 here and here. And I can place the 7 here, and that means that this is not a 7, so it's a 9. And this can't be a 9, so it's a 7. And there's a matching 1, 4 pair in this block. That means this cell can't be a 4, so it's a 9. That means I can get rid of the 9 here, here, and here. And this cell is an 8, which makes this a 7. Let's get rid of this 7, and this 7, and this 7. And now this cell is a 6. Let me go ahead and clean up the grid a bit. So now we have a bunch of naked singles. This is a 3. Let's clean this up. Here, here, and here, and here. And that makes this a 4. And then this is a 6. And this is an 8. And we have an 8 here. And down here a 9. And here's a 3. And then this is a 2. And now I have to clean up the grid a bit. There. Now we can see here, this is a 6. And let's see this up here and here. Now that makes this an 8. And this is a 1. And cleaning up a bit. And now this is a 6. Some more cleaning. And that makes this a 3. Then this is a 1. And this is a 4. And this a 1. And now this is a 5. And this is a 4, which makes this a 6. And 5, 2, 1, 4, 3, 5, 6. And then down here, this is a 1, 5, 7, 9, 1, 9. You see how this is all unraveling. Now what's left in this column? A 2, and this can't be a 3 or a 9, so it must be a 7, which makes this a 3. And then this is a 7, and this is a 9, 7, 9, and 8, and the puzzle is done. Wow, that was a nice one. Once we saw the unique rectangle, the whole puzzle fell apart. Oh, and let's not forget the swordfish and the XY wing. I hope you enjoyed playing along with me, or you can try this puzzle on your own. I'll leave a link to it in the description box below this video. Thanks for watching, and I hope you learned something.